here. Time make bootstrap test. Oh, well, I need to change directory. So first there, it compiled the runtime system, which is a combinator, interpreter, and memory allocator. And now it's, so when you do this, clone this, you get the combinators for the compiler so that you are not stuck there without the Haskell compiler. So now it's compiled once, and now it's compiling the second time, so you can compare if the bootstrapping succeeded and you have they all produce the same thing. Yeah, it worked. And it took just under 30 seconds to have the compiler recompile itself twice. And the combinator file itself is 136K, which is, I mean, the format is ridiculous. If you compress this file, it's down to 20K, so it's not that big. So,
is this in C?
Well, just like you, I've written the runtime system in C, but the compiler is written in Haskell, of course.
In itself?
Yeah. Oh. I mean, it's what you do with compilers. Okay, so let's to make it a little simpler, I'll make a compiler that has the combinators wrapped into oh no, what's this? It's not supposed to do that. Well,
Is that GHC talking? Or?
Yeah, I mean, you can compile it with GHC if you want. Let me run the compiler this way. We want to run the file comb/mhs.comb. Okay, and so that's to run the compiler. And now the arguments to the compiler, we want to have look for some libraries, and let's compile an example. I can show you the example here, Cat. I mean, it looks kind of like Haskell. Okay, so now we only compiled it, and now we can run it. So it does something. Let's recompile the compiler again. I mean, it's so much fun to recompile the compiler. This time with an extra flag for the runtime system, so you can see what's going on. I mean, you don't see, you get the summary of statistics at the end. You can see the number of reductions and things like that. It was quite fun to do combinator reductions after not having done it for like 50 years or something. Whenever I did that last, maybe 45 years. So you can see here that it reduces 424 million reductions per second. So that means that it takes only like 10 machine instructions per combinator reduction, which I think is pretty good. It allocated 1.6 gigabytes. I mean, its allocation is high, of course, as it always is. And you can also see here that about 1 out of every 4 combinator reductions allocates a cell. So the memory management is all based on cells. A cell has 2 pointers. So it can represent an application node, which is all binary applications in combinators. And 1 bit is stolen so that you can tag some things not being applications, but they're actually combinators instead, or integers or what have you. If you just want to see what's going on while it's compiling. You can pass it. You can see that it's processing things. You can see how many milliseconds it takes to compile the different files. So this is compiling sort of everything. There's no nothing is, there's no separate compilation. Separate compilation would be very easy to implement because the nice thing about these combinator things is that you can serialize anything, and the runtime system has that built in. So if you compile a module, you can just serialize it out to file and then reuse that again. So I think I've shown you almost everything I wanted to show you. And why would anyone be interested in this? Well, not to compile code to run, but if you want to have a sort of a compiler that you can hack around in that is 6 files instead of I don't know how many there are in GHC, and without any ridiculous comments, then or any other comments for that matter. So if you really want to make it tight, you can combine the runtime system with the combinator code that I showed you. Then you get the binary that is about 200K, and if you run that through the executable compressor called UPX, you'll get the binary that is about 45K. So 45K is all you need for a Haskell compiler. Well, most people would say, this is not Haskell because I haven't implemented type classes yet. So okay, maybe 50K when I've implemented type classes. So I think you should not ask why this is so small. You should ask why other Haskell compilers are so big. Oh, I should make one. Can look in bin here. You can see that, yes, this is the one compiled by GHC. It is, I have a hard time reading it, 21 megabytes. All right, that's it.
Certainly something to think about. Thank you, Lennart. All right, we have time for probably one question. Yes, we have. Javor?
Hey, that's very cool. I was wondering if you could say a little bit of how much of Haskell did you implement? So what is the MicroHaskell, so that we know how much we need to write a compiler?
Okay. So the big missing pieces are type classes and deriving. Then that means that there are some little bits. I haven't implemented list syntax with ... but that's sort of, and you can't have import lists on your importing. But I mean, there are little things that you can add that will not really make it any bigger. That would be very easy to add. So, yeah.
What part was the most fun, Lennart?
Hacking around in the C code. Oh, he asked what was the most fun part, and I said it's hacking around in the C code.
Quickly, just for a piece of historical verisimilitude, back in the early 90s, when GHC was just being born, what we spent our time doing was we'd release a new version of GHC, and then Lennart would release a new version of HPC, and it would be smaller and faster. And we would, so we would spend the next year toiling away, and then he'd do it again. It was always a very creative. So we just carry on this tradition. But I don't really want to compete on compile time anymore.
I should point out that if you recompile the compiler with the binary generated by GHC, it takes 0.7 seconds to recompile the compiler.